Good day, students. On this clip, we're going to go over how to graph and also convert between radian and angular measures. So this is going to be a review clip. So write down the lesson, the title of the lesson, review on graphing and conversion of angles. Okay, so this is the title of today's lesson. Alright, let's go ahead and take a look at two examples, and then we're going to go ahead and try some review problems. So let's write down the instructions for the examples first. So it is as follows. For the given angles, sketch the terminal side and specify what quadrant it lies in. Okay, so number one, let's take a look at 5 pi over 4. 5 pi over 4. So let's go ahead and graph 5 pi over 4. We'll make our coordinate system like this. I know that it's a positive number, so I'm going to be going up. So I'm going to start from 0 degrees, and I'm going to go up because counterclockwise is positive rotational direction. So this is 0 degrees, this is 90 degrees. Wait a minute. This is degrees and this is radian. This is, what on earth is this? How can I graph this? I think if I convert this from radians into degree measures, it would be more easier for me to graph, wouldn't it? So in order to convert, remember our conversion factors, we have two options. We either have pi over 180 degrees or 180 degrees over pi. These two are exactly the same thing, so I need to pick one of them to do my conversion, okay? Since pi is on the bottom, it would be wise for me to pick the second option with pi on the, since pi is on the top, I'll pick the one with pi on the bottom, okay? So I'm going to take 5 pi over 4. I want to change this to degrees, so I'll multiply it by the conversion factor 180 degrees over pi, and then I'm going to reduce, okay? So the pi's cancel out, and I multiply across. Do not cross multiply, please. Multiply across because you're multiplying fractions. 5 times 180 is 900 degrees. 900 degrees over 4. 900 over 4 comes out to 225 degrees. Now, isn't this easier to graph? Definitely is. Okay, so we're going to go 0 degrees, keep on going. 90, too small, keep on going. 180, you keep adding 90, too small, keep on going. 270, too big, we've got to back up. So 225 is somewhere here. To be precise, is actually right there in the middle. Right there. Okay? So to draw a spiral, it's going to go like this. Bam. Alright, so that is 225 degrees. What quadrant is this? We know this is 1, this is 2, and this is 3. So our terminal side is in quadrant 3. Okay? Alright, let's take a look at another example. Example number 2. What if we had to deal with negative 23 pi over 6? Okay? This is a negative radian angular measure, which will be somewhat complicated to graph if we're not familiar with the radian calibration of our axis. So let's convert this to degree just to make our life much easier. So to convert this to degree, I either have to pick this or this. Since it's radians, I am going to pick this option. So I'm going to pick this option because I want the pi's to cancel out. Okay, so I'm going to have 180 degrees over pi. Okay, because I want to change it into degrees, and then the pi's cancel out. If I multiply across, 23 times 180 so let's turn our calculators on and have it do the task for us. 23 times 180 is 4,140 degrees. So it's going to be negative 4,140 degrees divided by 6. If I divide that by 6, let's divide the answer by 6, our answer is going to be negative 690 degrees. So negative 690 degrees. Alright, so I think this would be easy for us to graph, right? We can graph this with ease. So let's draw a coordinate system. What will be the direction of our rotation here, starting from 0? Since this is negative, we're going to go down or counterclockwise, right? Down is a negative rotational direction. So 0, negative 90, keep on going, negative 180, keep on going, negative 270, too small, keep on going, negative 360. Uh-oh. We did a full circle and we didn't even get it yet. So keep on going, and negative 450. Too small, keep on going, negative 540. Too small, keep on going, negative 630. Too small, keep on going, negative 723. So we went too far, so we get it back up. It has to be somewhere here. So our terminal side is going to be right here. Okay? So what kind of spiral did we do to end up here? So let's generate it. We went full circle once. That wasn't sufficient. We had to go again and then down. Okay, my spiral doesn't look too good, but you guys get the gist. So there you go. This is what is it? Negative 690 degrees. What quadrant is this? This is the first quadrant, namely quadrant 1. So negative 690 is in quadrant 1. Okay. Now, thanks for paying attention to this. We're going to try some review problems. Hopefully this could help you out. Alright, welcome back, students. Now we're going to apply the formulas that I just went over. So let's write down the title of these examples we're going to do using the unit circle. Okay, using the unit circle. There goes the title of the examples that we're going to be going over today. Alright, so let's go ahead and take a look at some examples. Instructions for the examples are as follows. Find the terminal side, find the terminal point and value of the 6 trig functions for the given angles. Alright, number 1, we have 135 degrees. Alright, so we're going to first of all find where this point is on a unit circle. Hopefully it's there, and then we're going to use that point to determine the 6 trig functions based on the formulas that we went over. Alright, so first I want to do is find 135 on a unit circle. So everybody bring out your unit circles. Identify 135 is right here in quadrant 2. So what I'm going to do is I'm going to extract the coordinates. Negative root 2 over 2 and root 2 over 2, okay? So 135 is, parentheses, negative root 2 over 2, comma, root 2 over 2. Now, we need to label the coordinates. This is x and this is y, and we're going to use a formula to determine what all the 6 trig functions are, okay? Alright, we're going to start with sine. Sine 135. If you look at your formula sheet, sine is y, right? Sine is y. If you go up, it tells you right there that sine is y. I don't know if you see it. So sine is y. So sine is y, that simply means that the y coordinate is going to be our value for sine 135, which is root 2 over 2. Okay? And then cosine 135. What is cosine based on the formula sheet? Cosine is the x coordinate, which is going to be negative root 2 over 2. Two answers down, 4 to go. The next one we need is tan, the tangent of 135. By definition, using the unit circle, tan is the y-coordinate divided by the x-coordinate, or the slope from the origin. Okay? So to do this, we're just going to divide y, which is root 2 over 2. This is y, divided by negative root 2 over 2. Right? Y over x. This looks ugly because we have a fraction over a fraction. So how do we resolve this? So we can just DCF the problem, drop, change, flip, or multiply by the reciprocal of the denominator to address this. Okay, so if I want to drop, change, flip, I'll drop the top, root 2 over 2. Change division into times, and I'll reciprocate the denominator into negative 2 over root 2. That's what DCF, I like to call it DCF, drop, change, flip. So you DCF the problem, drop, change, flip, and then you have a scenario like this with two fractions being multiplied as opposed to two fractions being divided. Okay? Now what happens here? We have some cancellation action happening. 2 goes into itself once, 2 goes here once, root 2 goes here once, root 2 goes here once. If you multiply all these ones together, it's going to be 1, but there's a minus there, so it's going to be negative 1. Alright, so we have 3 answers down, 3 to go. Now we're going to find the reciprocal trig functions of these ones, okay? If you reciprocate sine, you're going to end up with something called the cosecant. Cosecant of 135 is simply 1 over y. Okay? 1 over y is 1 divided by the y coordinate, which is root 2 over 2. We have a fraction in the denominator, so it should be simplified. So to do this, I'm going to DCF this problem again. So it's going to be 1, drop the top, 1, times, you reciprocate the bottom to 2 over root 2. Okay, so you drop whatever's on the top, drop it, change the divide to times, flip the bottom, and then you get this. I have a integer times a fraction. Let me make this a rational expression, okay? Make it a rational number. So 1 over 1 times 2 over root 2. So that becomes 2 over root 2. Okay, we've reduced our problem into a simpler problem. Now this is a problem because you cannot have square root as a denominator, so we must rationalize the denominator, okay? So you times it by root 2, top and bottom. And our final answer is going to be 2 root 2 divided by root 4. What is the square root of 4? The square root of 4 is just 2, right? So it's going to become 2 root 2 over 2. Okay? So these two 2's match, they cancel out. And our final answer for cosecant 135 is root 2. Okay? Pretty long process, isn't it? Alright, so we're done with cosecant. Now let's look for secant. Secant 135. Secant 135 is 1 over x. Okay? Can you predict what it's going to be? It's going to be just like this, but the only difference is minus, right? So this one, the same thing though, is going to be negative. It's going to be negative root 2 for secant 135. Alright, let's assume that we weren't paying attention and we're just following the procedures just for additional practice. Let's do it again. So assuming I wasn't paying attention, to know that I was supposed to put a minus here. When I went through the whole step, I'll have 1 over negative root 2 over 2, right? So I have a fraction on the bottom, so I DCF the problem. So it's going to be 1 times negative 2 over root 2. Make this into a fraction. And then, if I multiply it, it's going to become negative 2 over root 2. But I may not have a square root as a denominator. So I square root the bottom and the top. And then that gives us negative 2 root 2 over 2. And then the 2's cancel out. And your final answer is negative root 2. Okay, so we knew that before. So that goes secant. Alright, let's figure out what cotangent is. Cotangent 135. Cotangent, the formula for cotangent is the reciprocal of the formula for tan x over y. Alright? So that's going to be, we know what our x and our y are. If you look at your notes, x is negative root 2 over 2. And y is root 2 over 2. So we have a scenario again where we have a fraction over a fraction. So we're going to DCF the problem, okay? Drop the top, negative root 2 over 2, times the reciprocal of the bottom, which is 2 over root 2. Alright, when you reduce this, you're going to have 2 goes here 1, 2 goes here 1, root 2 goes here 1, root 2 goes here 1. When you multiply all the ones, you get 1, but this minus makes it a negative 1. So there goes your final result. Okay? Alright, so let's organize our answers. So sine 135, cosine 135, tan 135. Alright, so let's see if we can remember. Sine was root 2 over 2. Cosine was negative root 2 over 2. Tan was, damn, I forgot. Negative 1. And then sine, and then cosecant of 135 is, or was, root 2. And then the reciprocal of cosine is secant. Secant of 135 is negative root 2. And then cotangent, which is the reciprocal of tan of 135, we got to just be negative 1. Alright, so there goes our answers. When you're doing your word work, I want you to put everything together at the end, just organize it like this for easy assessment. Alright? Okay, let's try another example. Let's take a look at the problem. Take a look at the example 2. What if we had, let's say we have 120 degrees clockwise. 120 degrees clockwise. Okay? So, where on earth is that on the unit circle? 120 degrees clockwise. 120 degrees clockwise. Let's draw a coordinate system real quick to see what 120 means. To see what clockwise means, okay? So remember, if you're going this direction, that is clockwise. No, that is counter. That goes against the clock, right? Counter clockwise. Counterclockwise is positive. If you're going down and around, which is the direction that your second hand goes and your minute hand and your hour hand, this is counterclockwise. This is clockwise. Okay? This is clockwise. So when you're going in the clockwise direction, guess what? Negative. So your clock goes in a negative direction. So 120 degrees negative 120 is simply, 120 degrees clockwise is simply negative 120 degrees. Okay? So where is negative 120 degrees on the unit circle? On the unit circle, everything is positive, right? If I wanted to go 100, this is 120, this is positive 120 degrees going round this direction. So what do you think negative 120 is? It simply means instead of going this amount of degrees, you're going to go the equivalent amount of degrees in the opposite direction. Or you just simply do a reflection of the positive downwards, okay? So if I reflected the positive downwards, that will basically give me what I want. So you see this is 120 right here. This is 120. If I reflected it straight down, that would give me negative 120. Okay? Okay, so let me show you using the unit circle what I'm talking about. So this is 120. This is the positive one. So the negative one is what you do when you just reflect it, reflect the positive straight down. Okay? A negative reflection is if it's up, it goes down. If it's down, you go up. So this is 120. The reflection downwards is negative 120. So this right here is negative 120 degrees. Because if you go from here, this angular rotation, that's positive 120. If you go the same amount of degrees the other direction, that's going to give you negative 120 degrees. Or you just reflect the positive downwards. If you're up, you go down. If you're down, you go up. Okay? So basically, what I want for negative 120 is this coordinate right here. That is the point I want. Negative 1/2 and negative root 2 over 2. Okay? Negative root 3 over 2. So let's use that. So for negative 120, we're going to have negative 1/2 and negative root 3 over 2. Label your coordinates. This is x and this is y. So now we're going to do the math. Okay? Alright, so let's start with sine. Sine negative 120. Sine negative 120 is your y coordinate, right? Which is simply negative root 3 over 2. Alright? Cosine negative 120 is your x coordinate, which is simply negative 1/2. Using the formulas that we just looked at. Tan negative 120, if you look at your formula sheet, is y over x, right? So what is that going to be? It's going to become negative root 3 over 2 for y divided by negative 1/2. Alright, so how do we address this problem? For this one, we're going to have to drop change flip, right? Because we have a fraction in the denominator. So let's drop change flip this problem. It's going to give us negative root 3 over 2. Drop the top, change divide to times, flip the bottom to negative 2 over 1. And then cancel out the 2s, just to cancel out. So minus times the minus is plus. Your final answer will be root 3. So your answer is root 3. Okay? Alright, next one. Cosecant. Cosecant is a reciprocal of sine. Cosecant negative 120, if you look at your formula, is 1 over y. Alright, so that's going to give us 1 over negative root 3 over 2. We have a problem here because the denominator is a fraction. So we're going to DCF the problem. It's going to become 1 times the reciprocal of the denominator, negative 2 over root 3. Put this over 1 just to make both of them fractions and multiply across. If I multiply across, you're going to have negative 2 over root 3. And now let's rationalize the denominator because you cannot have a square root to the denominator, okay? So root 3 and root 3. So your answer is going to become negative 2 root 3 over root 9, which simply becomes negative 2 root 3 over 3. And there goes your answer for cosecant. Alright, let's take a look at the next one. Secant. Secant negative 120 degrees. So secant negative 120 degrees is a reciprocal of cosine, so that's 1 over x. So that's going to be 1 divided by negative 1/2. Uh-oh, we have a fraction in the denominator again, so we have to DCF the problem. So you drop the top 1 times, you flip the bottom, negative 2 over 1. That's multiplying by the reciprocal. I make this a 1 also so that they're both fractions. If I multiply across, that gives me negative 2. This one is nice because I don't have any radicals on the bottom I have to simplify. Alright, last but not the least is cotangent. Cotangent negative 120 degrees is y over x. For our formula on our formula sheet. So that's going to give us y is, I forgot what y is, right? Yes, so y is negative root 3 over 2 divided by negative 1/2. Okay? So this one, we have to DCF this problem. We have to drop change flip or multiply by the reciprocal because we divided by a fraction. So we're going to have negative root 3 over 2 times the reciprocal of the bottom, which is negative 2 over 1. Okay? Now the 2's cancel out. And then your minus times minus is plus, your answer is going to be root 3. Okay, so your answer in this problem is root 3. Okay, so let's organize all answers together. Sine negative 120, cosine negative 120, tan negative 120. Let me see if my memory serves me correctly. This is negative root 3 over 2. This is negative 1 half. This one came out to root 3. And then your reciprocals. The reciprocal of sine, if you flip sine, you get cosecant, right? Cosecant negative 120 is negative 2 root 3 over 3. Secant negative 120 is negative 2. Last but not the least, cotangent negative 120 is, mistake. Yeah, I messed up the last one. It cannot be the same as that. So let's revisit this problem right here. So this one was supposed to be x over y. This is supposed to be x over y. Sorry about that. It's supposed to be x over y. So that's negative 1 half divided by negative root 3 over 2. And then when you DCF it, it's going to be negative 1 half times negative 2 over root 3. The 2's cancel out. So you'll be left with negative 1 over root 3. And then you times it by root 3, top and bottom. And then you're going to have negative root 3 over root 9, which is going to be negative root 3 over 3. Okay, so there goes the answer. So this one is negative root 3 over 3. Alright, so there you have it. Thanks for paying attention to this clip. Remember, it's uploaded on YouTube for your viewing pleasure.